Hello everyone. So in this video, let us talk about the first three problems from the latest Leetcode Biweekly contest 68. So the first problem is maximum number of words found in sentence. The problem statement is very simple. It states that you are given different sentences, as you can see. So you're given a vector of sentences and you just have to tell that every sentence has some words, as you can see, that first word, second word, third word, and this is one sentence. Similarly, one, two, three, four words in the second sentence. So you're given an array or a vector that is consisting of different sentences. You just have to count out how many words every sentence has and then print out the maximum words any sentence among all of them has. That's the whole problem. Now that is very simple. What you can do here is that you just have to find out how many words are there. So what you can simply do is that whatever sentence you have, let's say that you have Alice, so every word is accompanied by a space. So there's some space, then maybe there's and, then there's some space, then Bob, but then the string will get ended out. So what the better option is, because there's a last word also, so there is no space here, because as you can see in the last word there is no space. So you intentionally add one space in the end. Okay, and then what you do, you just iterate over this whole string using for loop and find out how many spaces are there. Because there are three spaces, it means that there are three words. You just find out the maximum among all of these sentences and that's the answer. So what you can see here is that this is the maximum among all of them. Iterate over every string and just check that what is the maximum number of word count in every sentence and just print the answer. Then this check function, what will do, it will first push back an empty space at the end of the string I want to find out the word count. And then what I'll do here is that iterate over this whole string. Whenever I find out a space, I will increment my total and just return the total amount of words I have, because the total amount of spaces is equivalent to how many words I have. Just keep in mind that I have to insert a space at the end of this string. Fine. Let us move down to the next problem. The next problem is find all possible recipes for given supplies. It's a good problem, but I don't think so that it should be for the second problem actually. The problem statement goes like this, that you have an information about n different recipes. Fine. Now you are given a string array recipes and a 2D string array ingredients. The ith recipe has the name recipe I, and you can create if all of the needed ingredients, that is ingredient of I, are all with you. Fine. Ingredients to a recipe may be needed to create from other recipes also. So that is the main thing that is also in this problem. I'll tell you more when you go to the examples. But you're also given that a string array supplies containing all the ingredients that you initially have. It is also given to you, that is initially have in your supplies. Return all the list of all the recipes that you can create, and you can print it in any order. Now just take the last example and it will become more clear to you. Okay, let us first take the first example. It tells that there is a recipe of bread, and to get a recipe of bread you need two things, yeast and flour. Fine. Now there is a supplies vector that is our array to you, that is whatever supplies do you have. It is also given that it is an infinite level of supply. So like yeast, flour, corn, you have infinite level. Okay, you do not have to count out how many level you have, but there is infinite level. But this is the amount of supplies you can get, the items you can get, yeast, flour and corn. Now if you want to, just have to tell how many recipes you can form, because as you can see, for creating a bread I need yeast and flour, and I have yeast and flour, so I can get bread. Fine. Let us move down to the last example. It will become more clear to you. As you can see here is that, let us erase this part. So I have the recipe of bread, sandwich and burger. Fine. Now ingredients, so this is also in this same order only. For creating a bread I need yeast and flour, that is fine. For creating sandwich I need bread and meat. Now bread, as you can see, is in the recipe. Okay, and then for creating burger I required sandwich, meat and bread. The supplies I have is yeast, flour and meat. Now what all items I can form? So let us say that I have the supplies of yeast, flour and meat. So yeast, flour and meat is the supplies I have. Now I want to create bread, whatever I can create. So as you can see, for creating bread I need yeast and flour. So from yeast and flour I can create bread. That is fine. Now what you can see next is that for creating a sandwich I require bread and meat. So from bread and meat I can create a sandwich. And similarly, for creating a burger, I require sandwich, meat and bread. So sandwich, meat and bread, all of them combined to get me a burger. Now, how you can like tell ki what all items you can form? So let's say that there is no yeast, then as you can see, you cannot form bread. If you cannot form bread, but because as you can see, then you cannot form bread, you cannot form sandwich, and you cannot form burger. So if you do not have yeast, okay. Similarly, like all of them are interdependent on you, on each other. Okay, that is the whole problem. How you can solve it out? That's the whole problem. Let us take some another pen. Now, in such a problem, as you can see that to form bread, you require yeast and flour. If you have a supply of yeast and flour, as you can see, then you can form bread. Similarly, if you have a supply of meat and bread, then you can form sandwich. And similarly, if you have like bread, like sandwich and like meat, then you can form burger. Fine. So it is some sort of a dieted graph. Okay. And then you just have to tell that how many like items or recipes you can form. So these are the different recipes. So the first thing which comes to my mind is in this type of dieted graphs is because I want to form in order. Because see, like I cannot form burger before forming sandwich. Okay. For forming sandwich, I need bread. For bread, I need yeast and flour. So it is like an in order traverse. So like not in order, but means that it is like every item is dependent on maybe some other item. And thatly one thing strike to my mind, that is topological sort. Because topological sort only has this property that you can get a graph, it is dieted and it is also satisfying that property. Also, for getting one item, it is dependent on some other item. It's like a prerequisite problem. It is already a problem on Leetcode, that is like what is the prerequisite of any course. So course scheduling, all of that, there's a problem right there. So that is the whole thing. Now you have to just apply topological sorting here, nothing else. So topological sort, if you remember what topological sort is, like if I just give you a very brief example, what topological sorting is, that if you have any graph, okay, then you just print out the order in which you take the node, such that any node that is dependent on that particular node should be after that particular node in that order. I'll tell you that, let's say that there is this type of thing. Okay, so what you can see here is that there are some nodes. Okay, now if you want to write on the topological sort of this thing, it actually means that to get this value, you have to first get these values out. So like this value depends on these two values. Similarly, this value depends on this value. Okay, so what you can see here is that a topological sort of this graph that is labeled as ABCDE, you have to first take A or B anything. Like you have to first complete A and B. So you can assume that these are tasks. So you have to first so getting the task C, you have to first complete A and B. So because A and B doesn't depend on anything, you can complete them in any order. So let's say I first complete A, then B, and then I complete C and D. Or I can first complete B. I first complete B, then A, then C and D. I cannot first take C and then D, or maybe I cannot first do D and C. Why? Because D depend on C. I have to first complete the first order, then only you can go to the next thing. Similarly, as you can see here is that for getting burger, I have to first get sandwich. For getting sandwich, I need first burger, like bread, sorry. I hope you get the point. So as you can see now, like topological sort is required here. Now topological sort, there's one very simple way to do topological sort here is that you need to find out the in degree of every node. In degree means how many like inward, as you can see, edges are there in every node. So as you can see, for all the supplies, okay, all the supplies, there is in degree of 0 because these are the starting nodes. As you can see, like there is no in degree, and all the recipes will be having some in degrees because those recipes depend on the supplies. I hope you get the point. So every, like you have to first find out the in degree of everything. As you can see, this is 0, 0, 0. This depends on two things. So it is like, as you can see, like 2. It depends like, and then there are 2 in degrees. For this, as you can see, that 2 edges are coming, so it is in degree of 2. Similarly, for this, it is depending on 3. So this is just like the size or number of ingredients I have. Okay, so these are 3 in degrees. Then what you can do is that you can use a stack. Not as you can see, not stack. You can use a queue. Sorry here. So I'm just using some sort of a BFS here. Okay, over this graph. Okay, so what you'll do is that you'll start out from the 0. like the nodes that are having 0 as their in degree, because those are the ingredients, and I want to move down this whole graph. So what you will do here is that you will first take out any of these nodes, and because it is the supplies, because I have first pushed all the supplies, I will first push all the supplies, that is yeast, flour, meat, in a queue. Okay, then what you will do here is that you will first start picking out elements from this queue. That is, the first element is, let's say, yeast. And what you will do here is that you will like delete out this node from this whole graph. Like, instead of deleting out, what you do, like if you delete out this node, whatever this, like wherever this node is connected to whichever item, you just delete out that edge. What I mean by this is, because it is connected to bread, if you delete out yeast, this edge will get deleted out. So the in degree of bread will decrease by 1. So you have some, like as you can see, some vector that is storing out the in degrees. And if you delete out some element, as you can see, if you pop out yeast from this, like this queue, you will delete out one value of the in degree from bread. Similarly, then because you delete out, then you will go to flour. Okay, and then you like extract out flour from it. Again, the in degree with bread is decreased by 1, because as you can see that flour is only connected to bread. Now, whenever this happens, that whenever you're extracting out or deleting out in degree of some element, if the in degree of that element becomes 0, what it actually means, because every element, like for repeating bread, I need these 2 elements. And because I have taken these elements from the supplies, those in degrees are deleted out, which means that bread, the in degree of bread is deleted out. What it actually means that now bread is prepared, because whatever items I have, from that bread can be prepared. Now, because I've deleted out both those edges, bread can be prepared. Now, because now bread becomes as a supply. I hope you get the point. So, because supplies are inserted in this queue, you will take this bread and insert it in the end of this queue, which means that now bread now becomes bread as a supply. You will like push that into the queue, and similarly you go to the next one. Hope you get the point. So that is how it all done. Like, and then you find out the next thing, that is meat. Okay, so meat is connected to this and this, so you will delete out both of these items, so which means that meat is used in both of them. So you will like decrease the in degree of sandwich by 1 as well as burger by 1. Okay, so sandwich in degree is deleted by 1, and burger in degree is also deleted by 1. So as you can see now, so in degree of sandwich is only by bread only, and a burger in degree is only by sandwich and bread. Fine. Now only bread is there. Now you pop out bread. Now because bread is popped out, what you can see here is that bread is deleted out. So bread is deleted out, which means that all the in degrees from bread, like out degrees from bread, are deleted out. That is, from sandwich is deleted out. So when sandwich is deleted out, sandwich is prepared. Okay, which means when sandwich is prepared, I will push that sandwich into the queue. And then when sandwich is deleted out and bread is also deleted out, so this is also 1 degree deleted by 1. And then sandwich is like taken out, so burger in degree will also deleted by 1, so burger will be inserted. And as you can see, like I have iterated over the whole map. And as you can see, whenever I will push this ingredient, like whenever I push an element that becomes a supply, it actually means that it was a recipe, but now it becomes supply. So because it was a recipe, I have to print out all the recipes. So before like pushing that into the queue, also push that into some answer vector, that is whatever recipes I can form. That is the whole solution for this problem. Let us move down to the actual solution. So as you can see, what I have done here is that I have made a adjacency matrix storing out from what recipes, like, because I want to make this graph. Okay, and this is the in degree map. Okay, so what I have done here is that in degree is just how many recipes I have. As you can see, like whatever is the size of the ingredients I have. So you can also print that. But because and this is the map what I can form. So map is giving, so as you can see, from every ingredient there is a direction towards a recipe, similar like this. So if I want to form bread, whatever ingredient, so yeast and flour, so there is a directed edge from yeast to bread and flour to bread. As you can see, from these are the ingredients. So from these ingredients, there's a directed edge from the ingredient to the recipe. Fine. And then there is this answer vector in which we'll store out all answers. This is the queue in which we'll insert out our supplies. So we will push all the supplies in this queue. What I'll do a while loop till there is some supply that is left. I will pop out the first supply, iterate over all the edges that are like connected to that supply that is stored here in this adjacency matrix. Okay, and then what I'll do, I will subtract out all the elements that is connected to that supply by 1, because that node is deleted out, so all the edges are deleted out, and thus which means that all the like elements or whatever like items are connected to that element by an edge are in degree deleted by 1. So in degree subtracted by 1. Okay. And then whatever, as you can see, if any of the items, the ith items in degree becomes 0, which means that all the elements are deleted out, what I'll do, I will push that element into the queue. Also, I will push that element into the answer vector. That is like, this is one of the recipes I can form. So also do that. And then just print out the answer. Hope you get the point how topological sort works and how this problem also like completed out. Fine. Coming on to the last problem. This problem also good. Check if a parenthesis string can be valid. Fine. So what the problem statement states is that you are given some parenthesis sequence, opening brackets and closing brackets, and then every opening and closing brackets, as you can see, has some binary value that it is either locked or unlocked. Locked means that you cannot change that what you can say brackets, which means that either it is open or closed, it will remain open or closed. But the unlocked brackets, you can change them, which means that you can change like whether it should be in the left opening or right opening, whatever like you want, you can change them. But the locked one, you cannot change them. Now the problem statement just brings down to that, can you manipulate the unlocked brackets so that the whole bracket sequence becomes balanced? That's the whole problem. Now in most of the bracket sequence, I know that they generally use greedy approach only. Okay, and also in this type of problems, generally there is greedy approach. So I try to think over in that like scenario only, or like in that direction only. And what I find out is, let us move to a drawing board to even make it some clear observations. Let us take the first example only. Let us delete out this part. So the first example is that there are two closed, then there is open close, and then there is close. Okay, so one observation what you can directly observe is that if the size of the string is odd, which means that then the answer is obviously no, you cannot make them balanced because it should be even. Okay, because if it is odd, how can I like balance every bracket with every bracket? Okay, so that is the one thing. So these are two closed, opening close, close. Fine. Then 0 1, and then 0 1 0 1 0 0. So which means that these elements that have the value 0 can be like changed. Like I can like change their like opening or closing, but the values that are 1, I cannot change them. Now the answer can this, as you can see that because this is the first, I can change them. So I can make it like this, opening close, and I can also like make this change, so opening close. And as you can see that it can be easily made like a balanced parenthesis sequence. Okay, now how can you do that? Now the first thing is, can you see that I cannot change the locked one? Okay, I cannot change the locked one. I can change the opening one, like unlocked one only. And unlocked one, I have the like power to change it in any way. Like I can open it, close way. Okay, so what you can see here is that what you can directly do is that iterate from left to right and count how many unlocked brackets I have, because I can change them in whatever manner I can want. Okay, so what you can do here is that iterate from left to right. Okay, so this is unlocked. So let us make some, that is like, let's say make some variable that is count, and there is some value that is equal to left, and there is value that is equal to right, or not left right, let's make it only balance only. Okay, what you can do here is that move from left to right. Whenever you find out a 0 value, that it is 0, so increment by count means that it is unlocked. I can do whatever it wants. I will not think over it right now, we'll think over it later, but we will only talk about the locked ones, because locked ones I cannot change. If the locked ones somehow make our problem like such that I cannot like change it, or like it is fixed. What I mean by this is, let's say that it is like this, two opposite ones, and it is locked. If it is like this, okay, then what can happen is that I can change the first one because it is unlocked. I can make it like this. But if both of them are locked, that is invalid. I hope you get the point. So what the better way is, I only have to think about what is like it is balanced, like it is locked or not. If it is unlocked, just count out, because if it is unlocked, I can like somehow like balance it out with the locked ones. But if it is locked, like it is a locked one, that I have to just count out how many locked or unlocked I have. Okay, so for if I'm moving from left to right, if I find out a opening bracket that is locked, I will mark it as 1. If I close it, closing bracket, I will mark it as -1. And if at any point of time my negative, like the total balance will tell me how many summation of positive and negative values I have that are logged. And if at any point of time it becomes negative, then the problem will come, I'll tell you. So what I'll do is that I will move from left to right. I will see that this is the value that is 0, increment my count value. Then it is 1. So it is closed. So which means that I have now a balance of -1, which means that I have a balance of -1 and I cannot bear a -1 because -1, which means that it is only closing in the left side and I cannot bear that. So what I'll do is I'll try to match this -1 with some extra I have that is unlocked, because only unlocked I can change. I will match that. Do I have some unlocked ones? Yeah, I have one unlocked one. So what I'll do is I will take this unlocked one, decrease it by 1, it will become 0, and match this with balance 1 because balance has become negative. So I will like add this to this, it will become 0, which means that I'll actually flip the previous one. It has become like this. So which means now balance becomes 0 because it is opening closing. So it is +1 and -1, so it becomes 0. And count becomes 0 because now I don't care about that. I have fixed that. Hope you get the point. What I'm doing here is that I will try to manipulate the unlocked ones with the logged ones. So I will just count out my unlocked ones because I can like change them at whatever like movement I can. But for the balanced one, what I'll do is that I will just like take them, not balanced, like whatever are the logged one, I just have to keep on track adding them. So now this is 0, which means that it is already like I can take it as a increment the count that I can use it any like further. 1 means that okay, it is again negative. So again negative means that again I have to count it with some balance, like is something extra. Yeah, when there is one extra, I will like count it out, it will again become 0, and yeah, I can again move forward. There's again some 0 values. 0 means that okay, I can like count it out as extra, like I will use it any later, that will become 1, and there's again one extra, I will make it as 2. Now in the end, as you can see, if I have greater than if I have like even value left, obviously I have the opportunity to like do it anything like I want, because it is even values. I can like do anything I want, and I will make this parenthesis balance. And thus if the value in the end comes out to a positive number, then the answer is correct, else the answer is like I cannot do anything. But there's one flaw in this value. What I mean by this is, let's say that I have like a string that is like this, let's say closing, okay, and then there is some closing value again, okay, and let's say if I have some closing value and then I have some opening value, okay, what I can do is that it is a closing value and like this, okay, or maybe like this only, okay. If this is, let's say it is fixed, okay, okay, no, if this is unfixed and this is fixed, okay, sorry, okay, let us say that it is opening, this is opening, okay, this is unfixed, this is fixed. Yeah, so what will happen in this scenario is that I have 2 openings, okay. Then what will happen is that this is fixed, so what I will do is that I will make my balance, because balance will only add if I have some fixed value, so balance will increase by 1, and then I have no problem because I only check that when it becomes less than 0, okay. Then I find out that there's some 0 value, so it means nothing. I will just increment my count by 1 and increment count by 1. So what actually happens is that I will tell that okay, my balance is greater than 0 and I have some count value, which means that okay, it is like easy to form, like I can form that. So this is correct. But if I mark this as also a 1, if both of them are fixed, then I will mark this as 0 only, but I will mark my balance as 2. If my balance become 2, I will tell that it is a positive number in the end, and I will tell that this is a valid value, but this is not, because 2 openings are not valid. I hope you get the point. So 2 openings are not valid, but in this scenario it will become valid because I will my count will become 0 and balance will become 2, positive 2. But I only balance out or check it if it becomes negative. I only check that if it becomes invalid. So the thing is that I'm looking from left to right, and then it like ignore this case. But if I move from right to left, then it will also take care of this case. So because why I'm doing this from right to left also, because right to left means that I am now checking that same thing. If this is right to left, this is 1 and 1. Now if I move from right to left, I will take this as a negative value, okay. This is a negative value. Negative value means that I have a negative value because I cannot make a bracket like this in the end. Okay, because I have to match it with something else, and thus it will become -1 from the back. Okay, if I move from left to right, like right to left, sorry, it will become a negative value, and thus what will happen in the end is that it will also give you a false answer. And thus you have to check this same logic, but you have to do it from left to right as well as from right to left. That's the whole logic, nothing much complicated. So as you can see that this is a solution. If the length turns out to be like odd, it is already false because I cannot match out all of these braces out. Else there's some extra in the balance value. Okay, extra means like how many like unlocked are there. So I'll move from left to right, and then whenever I find out a 0, which means that it is unlocked, I will just mark it as extra plus plus, that I can use it later. It is an extra. Else what I'll do is that if left to right it is an opening bracket, I will mark it as 1, or else it is a closing, so -1. At any point of time if my balance becomes negative, so what I'll do is that I will make it 0, and what I'll do is that if extra I have is like, if extra I do not have any extra, then I do not have any extra and my value becomes negative, my balance becomes negative, what I'll do is that I cannot make it balance, so I will like return out. Else if I have some extra values, I will subtract out some extra one, I will take out some extra value and then keep on continuing, because I have some extra value, I can use it to balance out the negative ones. Similarly, I have to do this from the right side only. And if both of these values pass out, like both of these for loop pass out from the left and right side, then only I will return true, else it will hit the false condition. Hope you get the point. So these are the 3 solutions for the 3 problems. I hope you get the solution as well as the intuition and the code for all the problems. If you still have any doubts, you can mention on in the comment box. Thank you for watching this video till the end. I will see you next one. Till I keep coding, and bye.